Welcome to this sample size tutorial for survival analysis in nQuery. In this tutorial, we will replicate a sample size calculation from a study in the New England Journal of Medicine evaluating Everolimus for the treatment of advanced pancreatic cancer, and show the various sample size calculations available for survival analysis in nQuery. Survival analysis is one of the most widely used types of analysis in clinical trials, where we wish to make inferences about the expected time to an event, such as death or cancer progression. This is a very common endpoint or objective in areas such as cardiology or oncology. There are many different types of survival analysis statistical models, including the log rank test and the Cox proportional hazards regression model. In this tutorial, we will focus on sample size for the log rank test, and some of the many different options available in nQuery to define the appropriate sample size for the log rank test. Before we begin, it's important to note that the sample size calculation for survival analysis, the power is related to the number of events, not the sample size, with the sample size being an estimate of how many subjects we think we will require to reach that required number of events. In nQuery, there are numerous different options available for sample size calculations for the log rank test. In this case, the researchers used a sample size calculation that was relatively simple based on the exponential model. In their study, they required a significance level of 0.025 at the one-sided level. They assumed an accrual period of 18.5 months and a maximum length of follow-up of 28.25. In other words, in months, they assumed that accrual would occur over 18.5 months, and that the study would be ended after 28.25 months. Note that this means that depending on when a subject entered the study, the maximum amount of time they could be studied for would depend on when they were actually recruited. For example, if they were to enter the study at the very start of the accrual period, at time 0, then the maximum amount of time that they could be followed up for is 28.25. But if they were recruited at the very end of the accrual period of 18.5 months, then the maximum amount of time that they could be studied is 9.75 months, or 28.25 minus 18.5. If a subject did not have the event or dropped out before the maximum length of follow-up is reached, then they would be censored. After we've decided how long subjects could possibly be followed up for, if they didn't have an event, we need to specify how likely we think the event was in each group. In their original sample size calculation, the researchers had based this on the median survival expected in each group. However, in this example, nQuery requires the exponential parameterization, where we look at the mean rate in each group. But nQuery provides a simple tool in the form of a side table to go between these parameterizations. This appears automatically below the main table in a side table when we select either of the two exponential parameter rows in the main table. In this table, we want to convert the median survivals of 9 and 6 months in each group respectively into the correct exponential parameters by entering 9 and 6 in the appropriate rows of this side table. In this case, we get exponential parameters of approximately 0.077 and 0.116, giving a hazard ratio of around 0.666 or 2 over 3. Once the table is complete, click Transfer to move these estimates into the main table. We've now replicated a study where the respective median survivals are 9 and 6 months in Group 1 and Group 2. We then set the power to 92.6 as per the original researcher statement. In this case, this gives a sample size of 176 per group, as per the original sample size statement, which gave a total sample size of 352. Or 176 multiplied by 2. However, remember that the power is related to the total number of events required, in this case, 282. In this particular table, we can also calculate the number of events independently of the accrual period and the expected rates, based simply on the test significance level, the hazard ratio, and the power. We've illustrated that by entering those parameters and seeing that the total number of events is calculated as per the original example. However, in nQuery there are numerous other options that can be used to explore different sample size scenarios for survival analysis and the log rank test. For example, we have a simulation tool that allows you to simulate a variety of different possible things that could occur and see what effect they would have on the power. In this case, we have replicated the original example where, in the side table, we have specified that up to 18.5 months, 100% of the accrual occurs, with the event rates being equal to the original values from the example before, with zero dropout. And then for the period from 18.5 to 28.25 months, there is zero accrual, but the event rates and dropout are the same, with the main table inputs being equivalent to those from the previous example. And you can see that the power is roughly equivalent to the 92.6 we saw in the exponential model. However, in this table, we could evaluate a number of more complex assumptions about what we think may occur in the study, including the effect of dropout or the effect of changing hazard rates. Let us say that in this study, for the first period from 0 to 18.5 months, that there is a dropout rate of around 0.05, reducing the power from the original 92.9 to around 81.6. Further, let's add an additional assumption where in the period from 18.5 months to 28.25 months in this final column, we assume that the event rates converge onto the control event rate of around 0.116. We can simply do that by copying and pasting the event rate in the group 2 exponential hazard rate into the group 1 exponential hazard rate in this 28.25 period. And this reduces the power further to around 79.4% versus the original 92.6% if we take into account both the effect of dropout and event rate convergence after 18.5 months. There are many other options available in nQuery for sample size calculations for the log rank test. For example, if you wish to compare the effect on power of using the log rank test to other linear rank tests, such as Taran-Ware or Guillain-Breslow, we can do that in this table, where we have also included the effect of dropout. In addition, in this table, we can see the effect of unequal sample size, where the sample size ratio is equal to 2 to 1 between group 2 and group 1. In addition, if you wanted to specify a fully piecewise calculation without using simulation, that is also available in nQuery. For example, in this replication, we have taken the original example with the same inputs, except that in the period after 18.5 months, we have set the hazard rate in both groups to be half what they were in the original study. And you can see that this has a fairly minor effect on the overall sample size required. There are many other extensions available for survival analysis, sample size calculations in nQuery, in terms of sample size calculations for the Cox regression model, non-inferiority, equivalence testing, and additional parameterizations in terms of specifying via the accrual rate rather than via the accrual period. In addition, there are adaptive options for group sequential design and sample size re-estimation, and Bayesian options for assurance, as well as extensions to these methods for the one group or greater than two group situations. To learn more about sample size and using nQuery for your clinical trial design, visit Statsols.com. Thank you for watching.